Hello viewers, my name is Dubisi Emmanuel. Welcome to my channel, Dubisi Online Math and Physics. In this video, we are going to teach on physics. Don't forget, in the last video, we talked about dimension of physical quantities. We stopped at velocity. So we are still going to continue from where we stopped. We are still on this topic. Someone will be saying this topic is too long. No, I'm just trying to break it down so that you understand. Is that clear now? So that you understand, not just to teach many topics, but for you to master many topics. So I'm not here to teach many topics. I'm here for you to what? To master many topics. Now, we are still on this unit and measurements. Unit and measurements. We are still on dimension. Dimension of physical quantities. Dimension of physical quantities. Now we stop about we stop on the velocity, right? Yes. We are going to start from number 3, density. How can we know the dimension of density? Before I continue, let me just write this clue here. Let me write this clue here. Don't forget this mass. In the last video, we talked about that. Don't forget this clue. Let me write it somewhere close. In fact, let me write it in the beginning. So this is what will guide us. Mass, meter, right? Mass is what? Kilogram. Then represented as what? Capital M. This will guide us a lot. Length, meter, as M, right? Then time, as what? Seconds, as what? T. So these are the things that will help us to navigate in any questions on dimension. We discussed it last video. Now, number 3, density. I told you that if you want to know dimension of any quantities, what we are going to do is to know their formula. Now, first know their formula. From the formula, you know their unit. And if you can know their unit without wasting time, just inside the unit and move on. No, so density is mass. Mass over volume. Density is mass over volume. That's density. Mass over volume. Don't forget that mass is kilogram. Mass is kilogram. Forget not that volume is meter cube. Volume is m raised to power 3 meter cube. We have discussed that in derived quantities and their units. Now, wherever you see kilogram, I told you, kilogram is you represent kilogram. Wherever you see kilogram with capital M, wherever you see meter with capital N, wherever you see seconds with what? Capital T. Now, you can rewrite this as kilogram per meter cube, like this. Kilogram per meter cube, like this. Now, kilogram per meter cube. Let's look for the dimension. We have gotten the unit of what? Density. Now let's get the dimension now through the unit of density. We get the dimension. Now, whenever you see kilogram here, you represent it with what? Capital M. Now let's go. Kilogram is what? Capital M. Meter is capital M. Then just this minus 3 still remain the same. So this becomes the dimension of what? Density. Very simple. So you say therefore the dimension of density is what? M per what? Per meter per L cube. M per L cube. So mn raised to the power what? Minus 3. M per L cube. Now let's talk about the fourth one. The fourth one is force. Let's talk about acceleration. Yes. Acceleration. What is the formula for acceleration? What is the formula for acceleration? Acceleration is change in velocity over time. So I told you that if you don't know the units directly, you can get their units from what? From their formula. So change in velocity over time, that is what? Acceleration. Now, we know that velocity is meter per seconds over seconds, which is what? Time. Now, from this, we have, don't forget that this is also what? Raised to power 1. So, if you have something like this, what I'm going to do is just pick this s, because this the base is equal, right? And it's joined together by division sign like this. So, pick one s raised to power minus 1. So, you subtract the power. The power is 1 here, a bit. Subtract it, which is what? Minus 1. So, this is minus 1 already. For this, we are picking 1. Then, what we are going to do is just subtract the power. Subtract this from this. That's all. You subtract this from this, you get this. Now, the unit of acceleration is, when you deal with this, you have meter per second square. So this is the unit of acceleration, meter per second square. Now, since you have gotten the unit of acceleration, as I have said earlier, if you know the unit, just go straight to the point. You know you're passing through this process. But because I want you to understand that if you don't know the unit and you still remember the formula, you can get the unit. Is that clear now? Now that you have gotten the unit, meter per second square, now we can get the dimension. The dimension of acceleration is here to be reviewed. Meter is length, right? Don't forget that. Meter is length, right? L, capital L, capital L. Now, seconds is what? Capital T, right? Now, capital T. So you can still, because this minus 2 is on S, and S is what? T. So replace this minus 2 like this and put it here. Just repeat it again. Minus 2. It doesn't change. So the dimension of acceleration is what? Lt raised to power minus 2. L per what? L per T squared. So this is it. Lt raised to power minus 2. And you can also see it like this. Don't be shocked if you see something like this. So don't be shocked. This is also the same thing as this. The same thing. They are the same. But most often they appear like this. Yes, they appear like this. They don't usually appear like this. And even if they appear like this, so it's also the same thing. Is that clear? So in our next video, we talk about dimension of force, power, and a lot more. So if you really enjoyed this video, thank you. Please kindly share, comment, and subscribe. So please subscribe so that if I post number 5, 6, 7, and 8, so you can be able to see it. So that's the value of subscription. So thank you. I really appreciate for watching. Thank you for watching. God bless you.